Hey all. Today we're going to go over making some basic comparisons within STATA and how to represent them both statistically and graphically. And this is going to be really your first step into sort of doing some very basic level actual analysis in terms of STATA outside of just controlling the data, shaping the data, and describing the data. So right off the bat, there's one thing I want to teach you that I noticed in the homeworks that will make both your life and my life in terms of grading easier. So I'm going to give you the first example of what we're starting with, but I'm also going to use that to sort of show you something pretty neat. So let's say we want to compare how two variables move. So the correct format to do that is to use the tab command, which you already know. And I'm just going to use age 6 as the example. Another warning, many of you who did the homework failed to include the analytic weights in data involving the GSS or the NES. You have to include the analytic weights or else the results are simply going to be off. Now the new part of the command, so you can see we're doing two variables in the single command with the format being dependent variable, independent variable. The new thing we're going to add is comma column. And you can see this kind of is big on the screen. We're going to make that easier in just a second. So what we've added is simply this column percentage. So you can see that for the 18 to 29 age group, 35% of them identify as Democrat, 38% identify as independent, and 25% identify as Republican. So the basis behind this is sort of intuitive. I want to see if age groups align in political parties differently. So are the youth more likely to be Democrat than the elderly? And at the very basic level, 35%, 32%, maybe not. But let's clean up this graph a little bit. So remember, don't ever have to type the command again. Just hit page up. But we're going to include in this time no frequency and also no key. So what this is going to do is going to drop off the total and it's going to get rid of the frequency. So you can see we can view it all on one screen. That's nice. That's good for what we want. Now let's make it even easier because this is a little cumbersome, but doing it graphically will actually be able to assess this out pretty easily. But just take a look at the data. If we just look at percent identifying Republican across the data set, we notice that we start with 25 in the youngest age group and go up to 36 in the oldest age group. That might actually be meaningful, and so we're actually going to take a look at that. I'm going to do a little housekeeping first. These variables are already included in the data set, but I want to drop them just so you get the intuitiveness of what we're doing. So tab, the party ID, make sure you have the analytic weight. And then we're going to generate a new variable, and we're going to call it party ID done. This is going to create a series of dummy variables for Democrat, Independent, and Republican. So it'll be party ID dum1 will be, every time it's a Democrat, it'll be 1. If it's an Independent or Republican, it'll be 0. Whoop. Yes, it is. We have to put a 3 there. There we go. So here's that aside. So let's say you wanted to put this in your homework. Two ways of doing it. One, copy as a picture and paste it as a picture, and I'll show you what that looks like right now. So we copied it as a picture. I'm going to go down here and say we just want to paste it as a picture. Bam, it looks exactly like a picture. You don't have to worry about cutting and pasting in any sort of odd way where it looks disgusting, frankly, when I try to grade it. And the way that I honestly prefer, just copy it, paste it, and that's what most of you did, just copied and paste it. But come up here and simply put Courier New, because that's the font it displays in. So you'll see that it'll actually display like it does on the screen. That'll save up file size too, in case you don't want to have an output of entirely just pictures. So just remember to change the font to Courier News, and you'll be good to go. All right, so I've created these series of dummy variables. Now I want to look at the Republicans. So first things first is we're going to go ahead and take a look at the relationship that exists. So we're going to tab page 6. So we're going to have, if I can type it correctly, so this will just give us the actual output. So this will give us the average, the mean of party identification of Republicans across these age groups. So we'll actually be able to look at it statistically. So we can see 25%, 36%. Not bad. But you notice that these aren't actually in percents. They're decimals. So let's go ahead and change that. So we're going to do that by replacing PIDDUM3 with multiply it by 100. So we simply multiply it by 100, which means that now that when we look at this, hey, look, it's percents. This is going to be really useful because when we try to represent it graphically, the fact that it's now in percent, so multiply it by 100, means that the y-axis will actually be a heck of a lot more meaningful to us. So how do we actually do that? Well, it's just an extension upon commands you've already learned. So we're going to graph bar mean of party ID and we're just going to put that over page 6. You can see the y-axis is mean. We could actually go into the graph editor and change that. We could change it to percent if we wanted to. Percent Republican. Bam. And then you could change the x-axis to be age. But what this tells us is that there does appear to be increasing identification with the Republican Party as individuals get older, noting the drop down in ages 30 to 39. But it does sort of show us that there's a positive relationship there. Neat. I'm going to stop the graph editor. I don't need to save that. And we're going to move on. So now we've compared an ordinal variable to an ordinal variable. You could do the same thing with an ordinal variable and nominal variable. Now we're going to do something with an ordinal variable and interval level variable. And to do those sorts of comparisons, you have to learn a new command. That new command is very basic, and it uses elements of all of the other commands we've done thus far. So we're actually going to look at party ID. I'm going to look at it 7. Remember, always use your analytic weight. And then we're going to look at it based on the sum of the feeling thermometer towards feminists. Now we can see that strong Democrats, their average approval of feminists is 71%, and strong Republicans, their average approval is 39%. So this would, well, intuitively be what we would expect to see, but we don't need the standard deviation, this frequencies, and these observations. So let's just simply get rid of them. So we'll say no standard deviation. Actually, no standard deviation, no frequency. I can type today, and no observations. You can see it just gives us the mean. It's nice and pretty. It works out great. Now, there are two ways that we can graphically represent this because we have an interval level variable. First is by a box chart, which is going to be the first time we've done that in the class, and the other is by a bar chart, which you should be used to already. So let's go ahead and look at that box chart. So we're going to graph it, box, feeling thermometer, feminist, analytically equals NESW over part 87. And there you are. That's how you would do a box chart. Now, a box chart provides you a lot of information. I love box charts because they provide you with the mean. They provide you with one standard deviation around the mean for each observation, and it provides you with two standard deviations around the mean, and provides you with outliers too. So just to give you a little bit, this line in the middle is the mean for each of these points. This is one standard deviation, so the length of the box, and the length of the stems is two standard deviations. So you can see there is a proportion of data that lies outside of two standard deviations in all of these areas. But it's a nice way to summarize data because it tells us a lot about the data. Box charts, while more complicated in terms of just visually, provide us with much more information than bar charts. So I would always lean heavily on these box charts if it were me. We can also do bar charts, and we would do that by doing graph, bar, mean, see, the command is not all that different. It looks very similar. The difference is with a box chart, mean is implied. That's what you're going to be looking for. With a bar chart, you have to actually tell it. And here's what that would look like. And you can see why I prefer the box charts over the bar charts. The box charts give us just so much more accurate information than the bar charts. The bar chart really tells us what the mean is, and we can see just graphically here that the mean is dropping. But what we don't see is how tightly that data is packed around the mean for each level, what the range is it skewed? We don't see any of that from this graphic. We just get the mean. Now, if all you're trying to tell the reader is the mean, then this is a fine way to present that data. But the box chart is always going to be able to tell you more data, more about the data than a bar chart will in this environment. So the homework asks you to do both of them, but understand for me, the box chart is far superior in this regard. Now we're going to look at smaller data sets and what we can kind of do with smaller data sets. So don't save. And so we're going to do this by looking at the states database. Now the states database only has 40 observations. There are lots of data points, but there are only 40 observations. So the commands that you're going to use here are exactly the same except when you get to the graphing commands, and then we're going to look at things a little differently. So let's take a look at pro-life stances across regions. Assume they're different. So we can see in the Northeast, 30% identify as pro-life, whereas in the South, 45% identify as pro-life. So pretty big difference depending upon region. Now, if we want to actually visualize this with a small number of data points, we can actually do so and see each individual data point, which I think is very important. So the way by which you do that is simply do a scatter. And we're going to scatter pro-life against region, but we're going to include a few other extra commands just to make your life easier, even if you're using the graphing editor. And that's going to be xlabel. We're going to tell you to use the value label, because if it didn't, it would just have 1, 2, 3, 4, which would correspond to Northeast, Midwest, South, and West. But now that we're telling it to use the value label, it'll automatically include those. And we're also going to tell it to jitter the data. Actually, I'm going to show you what it looks like without jittering, and then I'm going to jitter it for you. This is pro-life. Did I spell something wrong? Yes, I did. So There's the graph. You can see in the Northeast, things tend to be much lower than the Midwest, South, and the West seems to be pretty separated, which makes sense because in the West you have states like Utah, but you also have states like California. But what we don't see is the individual data points here. We can't identify them, but we can very easily if we just add the jitter command. And what the jitter command is going to do is it's going to take things off that line just a little bit. You'll see what I mean here. It pushes things off those lines so we can actually identify the data points. Now, if you were so interested, you could actually go in and or you could use a command and actually label the individual data points with the state ID like we learned last week. And so you'd be able to tell just by looking at this graph what state this is. You could even have it display instead of a dot the state ID. And so when you have a small number of data, this scatter chart, especially when it's jittered, is really useful to actually visualize how the data is moving. And the jitter command lets us sort of get even a better picture of that. So that's all the commands you need to do your homework this weekend or this week. It's the basics of making comparisons. Next week, we're going to actually look at making comparisons and drawing conclusions based upon hypothesis testing. And that's where this class really starts to get going. So I will see you all next week.